Howdy hackers, and welcome to another episode of FairLight TV. Episode 83 contained cracking tapes, but sort of the spin-off of that was the latter half, where I developed a transfer routine that would help transferring the games from tape to disk automatically. No need to crack the loader every time, just run the transfer and all the data was extracted to tape. I've spent more time on that, so this time we will go through the improvements of the transfer routine and what you might need to have, which you didn't have in the first one. So over to the extended transfer. In episode 83, we went through cracking the game Velocipede and also reassembling the loader routine for that, and then importing that, making it into a transfer routine. So that loader inside the transfer routine worked absolutely great. It worked super for the purpose of Velocipede. I then took the effort and then tried to find all the other options where Microload is used, and I found at least 20 instances where it's used. And I've now tested all of them. And there is sort of an additional need for developing the transfer, but we will get to that. The first step was that there were a few aspects of the transfer routine that I really didn't like, and I wanted to develop them further. One of the things is that there is a parameter in the loader that tells how many files it's going to load. And I just use brute force, and I hard-coded the number of files that was in Velocipede, and that is not correct for every game. So the first thing I did was adding a feature that would extract that value from the loader itself. The initial version just loaded the tape header. It didn't actually load the little file that the header is pointing at. So I had, but the value was in that loaded file. So I just had to load that, and I needed to load it on not the correct address. I needed to relocate it and then extract it from there, because if it would be loaded to the correct place, then the game would auto start, and then it wouldn't be a transfer anymore. So it needed to be relocated. So that is sort of the first thing I did. The second thing I did was taking the routine that parsed the file name and added a bit more rules to it, because I saw that a number of the other games had more control characters in the file names, and if you want to sort of automatically extract the file name and give the save files the name of the game in the file name, then you don't want the control character. So I added a bit of logic to remove the redundant ones that are more there to control the screen movement or the cursor movements. So that's handled. Yeah, and then there is also one thing about this loader. It starts loading one file, and then it calls that sort of first file. And then it loads all the files it needs, and then it calls the program. So the first call to what it has loaded is sort of an init. That could show a picture, it could or run something in the background. The micro painter, that is the example of Velocipede, is run as one of those programs. So I wanted to print the address that is called for that purpose, and also the address which is called for the start address. And it gets a bit squeezed, but you will see that. So let's just load another game. This is Big Top Barney, just showing you how the transfer works in the updated version. Okay, so let's just load the actual game and see how it looks. Okay, so Barney is also using it's using this picture and a little scrolly thing here, and then it counts down. It loads really fast because that is I'm running the emulator in warp mode, of course, but this would take a very long time if it wasn't for warp mode, and of course Microload adding to the speed here. Okay, and it's loading more, it's loading more, it's loading more. And there we go. So that's how this game looks now. So what I could do now is just reset. And then I have the transfer routine here. Let's see. And we can press play here again. So it found Barney. So it had a number of control characters, and they are now gone. I've extracted only sort of the textual part of it. So Barney, in it, as I said in the previous segment, that is what it's calling to run sort of in the background or setting up something. So the picture you saw and the scrolly messages, that is on E1000. So the first thing it will load is that portion, which it will call by calling E1000. And then eventually, when all the segments are gone, are run or loaded, then it will call ODB0. That's probably something I won't remember. So that would be something I would write on a post-it, so I would have that close. Okay. And here it's loading and it's saving, and you are now getting used to sort of the flashy messages here. I'm flashing the border based on I think sort of the checksum. That is sort of the flash from when it's loading, and then the flashing in the border, it's just incrementing for every 256 bytes. So it's just flashing to show that it's actually working. And you see here the start address and the end address of the stuff it is loading. So and again, keep in mind the sort of flashing it's doing here, because eventually it will stop flashing like that and it will flash in a very different way. Many segments on this one. So one of the things you could understand from this is that if I hard coded the number of files, it's very likely going to fail, because if I'm hard coding 3, then this is a lot more than 3 files. So this shows, this kind of flickering is showing that it's properly loaded all the files it was expected to load. So if your loader ends like this, flashing the border in this way, that means that the FA value, so number of files value that I extracted, was handled correctly, and it's exiting the loader after the proper number of files. If you see it flashing or stopping to flash without any flash such as this, that is sort of indicating that it didn't work properly. It should look like this when it's exiting. So that is because I extracted the FA value from that little file that the loader is using. Okay, let's see here. So here you see quite a large number of files. So the first one, the 0 one, it's likely, let's load that one. That one is supposed to be at E1000. So that is the picture and all of that. It's loading to FBFF. So the picture is probably on E1000, and then it couldn't be on E1000. Well, I wouldn't know. I haven't dug through that. But anyway, so this 0, if you're going to make a version of this game, you could easily skip the 0, because that is sort of that first instance of the loader entertainment. You don't want that. And then you just link up the rest of the files. So the loader now the transfer now works for the exact number of files that every program has. It is extracting that from the relevant files. But let's look at a few of the other things here. Okay, let's load Back to the Future. Back to the Future exists in a few different variants. This one is this one uses Microload, so this is the particular version of Back to the Future where this is applicable. So okay, so an init at C800, and then it's calling C8B0 for running the actual game. Yes, okay. Oh, that was ugly, right? So one of the portions now is loading into color memory, so D800, and then but that makes my code visible. So what you see now on the screen is actually my code that I sort of hid using black on black. So it wasn't visible before, but now it's really visible. It is saving properly. So what you get on the disk is actually proper, and you could use it for your crack if you want to. But this looks really bad. I mean, if this was something I just did for myself without releasing it, I would probably say that, well, I managed to transfer the game properly. So, and it is sort of extracting the number of files and it's saving them properly. So what do I care? Not good. Not, well, at least not perfect. Not good. Acceptable if it was for me. But if I'm giving this out, I wouldn't accept this. So we found an instance where the transfer routine is sort of failing. The solution for this would be to move all of the files so they would start loading from, let's say, 1000, where there is a lot of free memory. So it would never risk loading over the IO. Yeah. So I would add that to my wish list. Probably I would like to have something that loads, relocates the file before it saves it. But yeah, it's not super important, but highly wanted. Okay, one of the other games is Dandy. Let's just have a look at that. Press play. So now we're just going to watch the actual game. And again, I'm warp speeding this, so showing the picture. Yeah, I've seen that a number of times before. So that Mission Elevator was the first game I tested that was sort of not Velocipede, and it was exactly like this, showing a picture and then just loading the rest of the game, and it worked fine. So it seems like that's sort of a normal loader here, and that should work fine. So let's try to transfer that one. Dandy, and I can already tell that this is going to be an issue. Because the init is 0500, that is in the middle of the screen, and then the run is in 0518. That is in the middle of the screen. So this is going to load onto the screen memory where I have my code. And if I let it load there and not relocate it, my transfer will crash. So the transfer will not work on this particular game. Let's see how it crashes. Yeah, already there it crashes. So the transfer works really, really well for many of the use cases here, but I've already identified at least a handful where there is a quirk, those overloading the IO area, so the color memory here, and again, working but not looking very nice. And then we have this issue where it's loading to the screen and that crashes the transfer. The transfer will never work for that purpose. So if I want the transfer to work for generically for all the microloads, I need to fix it to also work to relocate. So I will now code the relocate function to my transfer. So relocation is now implemented. I've tested it with I think I have close to 25 games. Velocipede worked to begin with, but Back to the Future now works fully after relocation is added. And let's see, Nuclear Embargo now also works after relocation is added, and Tales of Arabian Night also works after relocation is added. So that's fine. Now the cases where it loads to color memory and it loads to screen memory, they are fully handled. And while implementing this, I found that I actually had a little bug in version 0.3. There is a classical bug named OBOB, off by one bug. So if you're going to save 10 bytes, if you're saving from 0 to 10, that would actually give you 11 bytes. So, but this was the other way around. I was saving 1 byte too little. Let's not go through that, but I mean, if you load stuff from Action Replay, if you've saved a file and it includes the data from hex 1000 to 1FFF, it will say loading from 1000 to 2000. So the end value you're given when you load using Action Replay is sort of not inclusive of the last address it's giving you. That's a bit weird, but that's the way it is. So the really awkward part is if you save the entire memory up to FFFF, it will say that it would load to 0000, so because it will warp around or wrap around. So relocation works, but we need to talk about these partly working. So a few of the games, when I extract the number of files, the value that is stored in zero page address FA for this loader. So if I say FA here, I just mean the reference to the loader's internal counter for number of files. It's not a general thing. It's not a kernel address that is using it for that. It's just for this loader. Exploding Fist and Vampire's Empire. If I let it pick the value, it says that it should load 1 file for both of them, I think. And then it would say that I've loaded all the files and I'm done. But it's not. So for both of those games, the first thing that it loads is a little segment, which sort of takes control over the rest of the loader. And that has sort of the internal handling of the number of files it should load. The FA value is not reliable anymore. So there are 2 ways to mitigate this. First, well, 3. You could say that, no, we don't support those 3 games or 2 games. But that was not my ambition. It's also quite clear that the automated solution did not work in this case. So the other option is to sort of override that by just setting the value to something extremely high, like 256, and then it would load all the files, but it would still try to load more because the loader wouldn't be, or the transfer wouldn't be aware that it has loaded all the files. And the third option would be to scan that first loaded segment and then try to find the new number of files deriving from the content of those. And the option to that would be to have some sort of database or special handling for these 2 games or 3, wherever. Well, to be honest, I picked the middle option because that's implementation-wise, that is sort of the easiest thing to do. So when you load it and when you get to the screen where it flashes and expects you to press a key where it says the name of the file it has found and the init and the run address, if you on that screen press run stop rather than pressing space, you are skipping the smart detection of the number of files. It would just poke FF, so 256, in the counter, and then it would keep trying to load all the files that would be on the tape. So you wouldn't have it like a clean exit of the program. It would just stop. The transfer would just stop or sit there and wait for additional files, which never comes. So that actually works. So Way of the Exploding Fist and Vampire's Empire now works fine as well. Movie Monster Game is a two-sided game. So yeah, it does transfer a number of files, but I haven't been able to validate yet, and I haven't run it on side 2 of the tape, so I wouldn't know if it would pick up anything from side 2. I'm a bit hesitant it would actually. So the only issue I have now is the game called The Prodigy. It is transferring like 2 files and then it just resets. There could be an issue with the original that I have, the original tap file I have for this. But if I load it using the emulator, not using the transfer, then it loads fine. So, I mean, it could be that one segment of the loader is... one segment that it loads has a CRC error, and that is what triggered. But then it should not trigger just the transfer. It would trigger also the plain loader using in the Prodigy. But yeah, so that is still something I work on. But I would like to show you how one of the games now work, especially one of those where it's handing over control. So over to that. Okay, so let's do Way of the Exploding Fist here. Let it find the header and... Okay, so here it found it, and you see here there is an init, and then there is a run. I just press space now here. And you see here that it's saving a file from C1000 to C5, and then it's done. And of course, the game couldn't be just like 1K or 1.25K here. It has to be bigger than that. So there is an issue with transferring that. And that is, as I said before, that the file I've loaded now is just the thing which then keeps control over the rest of the game. Yeah, let's see. We're loading that 0. I've actually increased the font size of the font now, so I hope you can see here. So it jumps to C1. So it's setting. So C1 is. So this is now what sort of keeping control over the loader, feeding it with values, and using the stuff that is in the lower memory, but it's sort of managed from the top memory now. It's doing that, and then it's jumping to CO65. There is a lot of knobs. This looks like it's been coded in a machine code monitor, because nobody would code with this many knobs. There is absolutely no point. It's setting values again, and yeah, without trying to understand every piece of this, it's now jumping to C140. It's doing a lot of things. So jump JSR to C006. I think that's just loading another file. So that is rather than the internal counter, it's calling the loader a number of times, or it's setting up the loader and then letting it run, and then you have a new file in memory. You see it also changes colors here between the calls to this routine. So it's setting black, calling that it's black again, and then what is that, cyan or something? Okay, and it's setting stuff in memory. And then one of the key things here, it's doing a jump to subroutine to 9000. So yeah, so 9000, we make a note of that. Yeah, it's jumping to subroutines here again, and yeah. And here we suddenly run into something interesting again. Jumping to 115A. That is actually the start address of the game. So here you see it. it is starting on 115A, and this is not in the loader as we saw before. It is sort of in the first file that the loader loads. C366, yeah, so C366, this is turning on and turning off the screen. That's sort of a support routine, but it should load a number of files. So let's see the file we have here, and oops, 0 point star. So we're just deleting that, so because I don't have save with replace. That could be a potential wish as well. So let's run the transfer routine again here. Play. But rather than pressing space, I'm now going to press run stop or escape in my emulated environment. And there you see, it's now transferring a lot more files. 6,000 to 8710. I'm pretty sure that is the exploding fist picture. And then there was something at 9,000. And as we saw, there was a jump to subroutine to 9,000. I would be willing to bet that that is showing the picture. That is setting up all the graphics for showing the picture. Possibly also copying it around so it's not sort of in the way. Yeah, let's have a look at that one. I don't remember the index of it, but let's see how many files there are. There you see, 0400 to 8000. So this one also loads to screen memory, which means that without relocation, this would fail horribly. Yes. And there you go. The screen is not flickering anymore. And we can see here in the emulated environment that we've reached the end of the tape. And as we don't have anything that keeps track of the number of files, we never reach that flashy border that indicates that we have a healthy transfer. This is one of the exceptions. We needed to bypass that. So I think we could now say that we have all the files. So these are the files. And if you want to make a working version of Exploding Fist, these are the ones that we need to set in the proper location at and then skip the ones that we don't need, that were just part of the picture. Then we can have that as a separate one. They shouldn't be in the main file then. Yeah, let's do like this. We load, and then I'm going to add 2 breakpoints. So break 9000, and I should do break 115A. These are the 2 notes I've done since going through that first file. And we can do play. Exploding Fist. Okay, so there was something showing the instructions as well. That's probably part of this C file as well. I should... Okay, so this is 9000. My guess is now that 9000 contains the instructions for kind of showing the screen. 928. Yeah, it's doing... Okay, setting up new parameters for the timers. Was there any sound? I wasn't aware. Let's just... So you see, what happened there was that it did actually show the screen. And yeah, so somewhere in the code, it did set the values for the screen. So you also see the stopping of the flashing of the border. That is when it's sort of setting, downloading one segment and loading the next one. So let's see. 79, and here it also used this turning off of the screen. So here it stopped just when I called, or when the machine called 115A. If I understood the logic here, if I press X, that is, we are actually at the very point of where the loader hands over to the game. So the game should start immediately after I press X here. And it does, yes. So we found the actual load start address, but this is one of the cases where we really need to go through the sort of additional logic here in this 0 file, the first file we transferred. Great, so we managed to transfer Exploding Fist. One of the games I had a bit of an issue with was Dandy. That one is doing something, it's loading something to 0500, and that little thing then corrupts the loader. So after relocation, Dandy transfers fine. But in order to make sort of a working version and validate that everything worked, we're going to have a little look. And let's see here. There we have it. So we load 0 from device 8, and we see 0500. So this one is doing the comparing with FA, and then it's jumping to subroutine 2000, and it's jumping to subroutine to 2000, and then it's sort of doing a little bit here. Well, it's basically setting color memory to, or color to black. It's resetting, or all the way down here, it's resetting vectors to standard values. The label you see here is sort of an artifact that I have loaded the transfer, and then all the variables for my transfer is still here, and even if the program is not here, because this is overloaded with Dandy code, they are still here in the machine code monitor. Okay, and then we have the last thing here. It's doing a jump to 1113. So let's see how that would work. So here I loaded that to the screen, but we don't want that. We have a vague understanding of what that is doing now. So let's look at the files. So file 1, it's loading to 2000. And this routine called that. There we go. It is doing something. It is showing a picture, and we might want to have a look at that. So what it's doing, it's first of all, it's flipping 01, but we don't need to care about that. But it's taking stuff from 40C0 and storing it to color memory, and this is already, this is this section here. The next thing that happens is that it takes from 2180 and then stores to E1000. And then it's a lot more of that. It's copying stuff. Yeah, so this is a big copy routine that copies. So it copies the color memory from one portion of what it has loaded, and it takes the bitmap value from other portions and copy that to E1000. And then, yeah, jump, because this is a long one, so you can't have a branch. You need to do it sort of the other way around. You branch if you're done, rather than branching up. And yeah, let's see, I skipped that. And now it's sort of setting, yeah, bitmap mode and relevant bank, and yeah, sorry, this is bitmap mode, and this is pointing to the relevant screen memory, I think. Okay, so what you have here is transferring data all the way up to E1000. So the only thing that's in actual computer RAM is now the thing on E1000, because color RAM, I don't count that as normal RAM here. And then it's showing the picture. There is, as I understand it, there is no screen, right? So this is only, this is a high-res bitmap where you don't need that. So the stuff that is now on 2000 is no longer used. So all the thing it uses from this is on E1000 and in color memory. which is fine. So now we know that we have bitmap and color memory here, and nothing the rest of this file is actually needed. Okay, so we can do fill to from. Okay, and let's have a little. Oh, yeah. I was filling from 100. That's not going to be ending well. Okay, so that was filling already from from the stack, and that will fail everything. So let's load file 2, and let's so the next file it's loading is and that one is also called using JSR to 2000. So that one is taking from 2100 and storing it to D1000. D1000. But the little weird thing here is it's storing to D1000, D1, D2, D3, D4, D5, and then nothing more, and then DD, DE, DF. So the RAM under the IO block, it uses the first portion and the last portion, and then there is sort of a gap in between. And then it's copying a lot from C1000 all the way up to, yeah, CFFF. And then it's returning. So what this is doing is it's loading stuff into like plain RAM, copying it up until the higher memory, especially the area under IO, which is a bit tricky to handle, especially if you're doing it during a load. So we can actually do something like this. We are now I just called the routine, and now it's done the copy to the high memory, and then I can load 3. And now I have, because I cleared the memory first, right? So there is no artifact of anything, and this file 3 loaded fully over the original place where file 2 was, and file 2 has copied all the relevant content to the higher memory. So if I now save from, oh, and I shouldn't have warp on, main, and then I think this is the start address, comma 08, comma 008, comma east 1000. And then we can put warp mode on, so we don't need to listen to the sound of the saving drive. Let's go. Hey presto! We now have a working version. We have a file on the disk that should work. And then we all dungeons, and then the game actually starts here. So that's a working version of Dandy. Now I just need to implement trainers and add my intro and what have you not. Yeah, possibly I should make a working version of Dandy. I'm just having a look in CSDB and see if there are other good versions, if it's worth the effort of actually doing that. But yeah, that's the working version of Dandy using the FairLight TV Microload transfer. So it seems that Hokuto Force has done an absolutely amazing version of Dandy. So my initial plan of making that as a kind of trial for showing you the entire process sort of failed, because yeah, there is no way I can compete with the Hokuto Force version. If I'm doing or investing a massive amount of time, I can get an equal one, but not a better one, because it's absolutely perfect. It has all the maps, they fixed a number of original bugs, and they seemingly played the game immensely much to actually find all of the quirks that were in the original. Fixed it some 30 years after the game's release. So I won't do that. So But what I can do is ask you to ping me and ask for the GitLab repository references so that you can pick up the transfer yourself if you want to have it and see it and learn from it. I have scanned through it, but of course having the original source code is a lot easier than trying to retype it from a video. So do contact me for that on YouTube. That's probably the easiest way to do it. Just comment and a link will be sent to you. Thank you so much for watching and hope you enjoyed these 2 episodes of making a transfer. Bye-bye. But wait, there was something else. Yes, yes, yes. Let's see, version 0.6. There is a change. What could that be? Let's see what happens when we do like this. So the game Prodigy, that was one of those, or the one, where I complained that the transfer actually didn't work. So I have fixed so that the game now works. Let's find the root cause of why it didn't work. So transferring 1000 to 4400, that worked before, so that's not new. And then this process was rather long and yeah, something, well, quite far into it, it just borked. It didn't work anymore, so I had no idea why that happened. And now we have the reason. So I had used buffer from 1000 and upwards, which means that if I relocate this, which has the start address of OB00, that means that my file would be extending way over the VIC chip, and that freaked things out. So what I just did was change the buffer to start from 0800, because the stuff that is on 0800 in my transfer is just the kind of the discovery of the header and a number of routines related to that. So there is no problem in actually changing the start address to 0800. And now it's quite fine. It's transferred everything and it terminated the transfer gracefully. So let's just see. We do have 199 blocks. So the issue was that my transfer didn't support the like 202 block files or anything close to that. I think the maximum would be 184, 85, something like that. But now it works. Transfer version 0.6 available on GitLab and available to you if you just ping me or comment the video. So I would be glad to talk to you about this. See you next time.